Okay, everybody's favorite airplane relative motion type problems. As we said in lecture, the key is to get a good diagram drawn and everything labeled correctly. And in fact, right in here, we require you to do that. So let's write down our knowns now and see if we can get a good diagram, then work through the numbers. So an airplane can fly 230 miles per hour, still air. So velocity of plane with respect to the air is 230 miles per hour. It leaves the Knoxville airport with a heading of 40 degrees west of north. So that's actually the heading, not the actual effective direction, but that's the actual direction of this plane with respect to the air. Okay, so there's north, west of north is to the left. Okay, so that's the heading of the velocity of the plane with respect to air. We're told that you're flying to Chicago, it's 450 miles away, and it's 24 degrees west of north of Knoxville. Alright, so the velocity of the plane with respect to ground, or how it's actually traveling, is 24 degrees. Okay, west of north. We know it completes it in 2.3 hours. We want to find the magnitude and velocity, the wind velocity, both magnitude and direction. Alright, so if you take a second to think about this problem, we have one more thing that we don't know. We don't know the velocity of the air with respect to the ground. Okay, but let's draw a diagram now. So velocity of plane with respect to ground. So velocity of plane with respect to air plus the velocity of air with respect to the ground. So this is the wind. All these are vectors. Alright, so we know the direction of the plane with respect to ground. So I'm going to draw that right here. We don't know its magnitude, but we do know that it's 24 degrees. Okay, I'll switch colors. Okay, we know that we head in 40 degrees. Alright, so this green angle right there is 40 degrees. Okay, we know the magnitude of that one is 230 miles per hour. And we know that, and that's the velocity of the plane with respect to the air. And we know the velocity of the plane with respect to air plus this wind velocity has to equal velocity of plane with respect to ground. So to add vectors, these two vectors right here, they're going to equal this vector right here. These two vectors need to be head to tail. So I would connect this like that. So that's the velocity of the plane with respect to air. That's a key point. We know one side of this triangle now, and we know basically two angles. Okay, let's work through what we know here. Okay, I'll back up. I knew I was jumping ahead. I only know one angle here. I know that 40 and that 24 will make this interior angle 16 degrees, but I don't know that, so I really don't have enough information. The key point here is, and I actually forgot to write it down, is we do know this 455 miles, and we do know the time. So we can actually calculate the velocity of the plane with respect to ground. We're covering 455 miles in 2.3 hours. Okay, so we didn't give you it directly, but we gave you a distance and a time. 455 divided by 2.3 is 197.8. Okay, miles per hour. So we know this value right here. So my diagram, since I didn't quite have that yet, is a little bit out of scale. We're actually flying into the wind a little bit, and it's blowing us to the east as well. But the numbers will all work out here. So I've got law of sines, law of cosines. I know these two sides. I know the angle opposite to the plane with respect to air. So I can write an equation: plane with respect to air squared is equal to 230 squared plus 197.8 squared minus 2 times 230 times 197.8 times the cosine 16. Okay, if I solve velocity of plane with respect to air right there, 230 squared plus 197.8 squared minus 230. Okay, that gives me a velocity of the wind, or speed of the wind, as 67.5 miles an hour. So there's the magnitude. Okay, I need to get, should have drawn this a little bit larger, but I need to get this angle right here. Alright, I know if I switch back to green, I know this angle right here is 50. So I know this angle is 50. So if I could find this interior angle of the triangle, I subtract 50 from it and I get my heading. So law of sines to find that. So I'd have my 197.8. Let me write it the other way here. We'll call that angle theta. So I know sine of theta over 197.8 would be equal to the sine of 16 over, so that angle over the one I just calculated, 67.5. And I get my theta working through that. Let's see, sine 16 divided by 67.5 times 197.8, inverse sine. 53.9. Okay, 53.9 degrees. And so my heading would actually be 50 minus that. So the angle for the velocity of plane with respect to air would be 53.9 minus 50, or 3.9, and that would be north of east. Alright, so a lot of work, but here's your final answer: 67.5 miles per hour, 3.9 degrees north of east.